All right, ladies, you're in charge of that. All right, inverse trig functions. It's been probably a while since you've dealt with those. So f of x equals sine x. Normally, with the regular trig functions, you input an angle, and then the output, whole thing here, is a ratio. If you're dealing with triangles and you say you're looking at sine, then the output is the opposite over hypotenuse. Okay, that ratio, those numbers, two numbers divided by each other. If you're looking at angles of rotation, then it's going to be the y value on the terminal side divided by the radius, the distance that that point is from the origin. Okay. Cosine, it's adjacent over hypotenuse, or the x value over the r value. Tangent, it's the y over the x, or the opposite of adjacent. You all remember this kind of stuff? So, yeah. So the input is the angle, the output is the ratio. Now, if you remember in pre-cal, we talked about the inverse function, which goes the opposite way. You input a ratio, and it outputs an angle. Yeah. So, looking forward, you might say sine of 45 degrees is root 2 over 2. Input the angle, output the ratio. With inverse sine, you would say inverse sine of root 2 over 2, and the answer would be 45 degrees. With there are also some things that we had mentioned before with the inverse sine. Sometimes it's called the arc sine function. There is a restricted domain. Basically, you're only allowed to input ratios between -1 and +1. And the reason is because that was the range of value. So let's think about, if you think about the good old-fashioned sine function, right? Start, 0, end at 0, in the middle you're 0, your high value is 1, your low value is 1, and that just keeps going on and on and on. What are the only output values that you're getting, or what's the range of values you're going to get on the output?
1 to -1.
Yeah, -1 to +1, and so because of that, those are the only values that you're allowed to put inside here. Okay, you can only put in values between -1 and +1. If you try it on the calculator, you try to do inverse sine of 2, it's going to give you an error because you have a restricted domain. Okay. The graph of inverse sine looks kind of. It's as if you kind of did that whole back and forth. It's kind of as if you do that, but it's only from -1 to +1, so it's only that region right there. As if you took this whole thing and kind of rotated it. So it's a little more curvy than I was kind of making it seem. Okay. But we already know the derivative of sine, and that is cosine. So now we're curious, what's the derivative of inverse sine? Maybe it's inverse cosine. And we're going to have to do a whole lot of work to be able to show that it is. Maybe, or maybe it's not. Maybe it's something different. I don't know. I guess what we could do, as we sort of has been our habit as of late, is to kind of do some local linearization. That's a terrible park fiction. Anyway. That's kind of what it looks like. If you think about it, that's the graph of inverse sine. But got some negative values, and then over here to 0, and then some more negative values. Okay, so these values a lot steeper, so like maybe -1, -0.5, -0.1, and then these are going to get steeper, so like maybe -0.1, -0.5, -1, I don't know, something kind of like that. That would look, so if we have -1, -0.5, -0.10, -0.1, -0.5, that would look something kind of like that, maybe. I don't know, we're just kind of eyeballing it, seeing what it might look like. Alright, so let's go ahead and get about the business of figuring out what the derivative is. This is a pretty weird proof, just going to tell you. But let's go ahead and get through it here. So, y equals the inverse sine of x. Let's go ahead and draw a picture and just think about what that means. Couple things. One is inverse sine, just as I mentioned a few minutes ago. What is the input on inverse sine?
The input would be a ratio.
Yeah. So the x over 1, that's the ratio, ironically, of the y value over the r value. Okay? So it's weird, but I'm going to put an x right there, and I'm going to put a 1 right here. Ooh. What does the y over here correspond to? What is the output of an inverse sine? Sorry, inverse sine. It's the angle. Right? So the whole thing all together is the angle. So I'm going to put y right there for the angle, because that's what that means. And then we're going to do Pythagorean theorem to figure out what this length is. Okay? So we'll say question mark squared plus x squared equals 1 squared. So question mark squared equals 1 minus x squared. So question mark equals, I guess you could say plus or minus the square root of 1 minus x squared. Based on our pictures, is it going to be plus or minus?
Plus.
It's going to be plus because we're kicking it that way. So question mark is square root 1 minus x squared. Alright? Going back over here, I'm going to take the sine of both sides. So the sine of y is equal to the sine of the inverse sine of x. Alright, now something that you remember, inverse sine, those inverse functions, okay, they go from the range to the domain. They're the inverse operation of the original function. So if I have x and I do the inverse sine, I take it over here, but then I take the sine of that, takes me right back to where I started from. Anybody want to make a guess what this right hand side is going to be?
It's going to be x.
It's going to be x. So sine y equals x, or sine equals x. Then we'll take the derivative of both sides. So what's the derivative with respect to x of sine y? Cosine y. Now y is a function of x, so times dy over dx. What's the derivative of x? 1. So, getting that up here, dy over dx equals 1 over cosine y, or cozy. And so we're like, all right, what is the cosine of y? Well, here's y, right here. And the cosine is going to be, what you can think of the adjacent over the hypotenuse, or the x value, which is what we're looking at here, over the r value. So that's 1 over, and then square root 1 minus x squared divided by 1. Anything divided by 1 is itself, so it's just going to be 1 over the square root 1 minus x squared. Alright, so it does have a relationship to cosine, but it's not inverse cosine. So here you go. The derivative of inverse sine is 1 over the square root 1 minus x squared. Sound good? And you know what we could do? What if I put a u right there? Derivative of inverse sine of u is 1 over the square root 1 minus u squared
times u prime.
Times u prime. You can add that to your blue sheet. Well, Rosa, is that what we expected?
No.
No, that is not what we expected. We expected like inverse cosine. Yeah, no, these are ugly. These, oh, we don't like, I mean, that's just, okay. So there's, there you go, there's inverse sine. Let's go ahead and do, inverse cosine, shall we? So, y equals inverse cosine of x. Now everything's going to get nice. It's going to get faster because there's a lot of similarities between this one and last one. Alright, so based on what we saw before, so this is the ratio. So I've got that's the ratio of the x over r. So the x is in the x position. Hey, that's nice that it actually is. 1 is the hypotenuse. Okay. And here's our y value is the angle. We could do Pythagorean theorem, but I'm pretty sure it's going to be the same thing as before, right? I'll put a question mark right here. Question mark squared plus x squared equals 1 squared. So question mark squared is 1 minus x squared. Question mark equals plus or minus the square root of 1 minus x squared. Is that kind of the exact same thing? It's going to be positive. So we kind of base this one off the same process that we did last time. We'll just take cosine of both sides. So cosine y, when I take the cosine of, cosine of the inverse cosine of x. So cosine y equals x. I'll just say it rather than writing it. Let's take the derivative of both sides. What's the derivative of cosine y, class? Negative sine y times dy over dx. Derivative of x. 1. So dy over dx is going to be 1 over negative sine y. So that's negative 1 over. So sine is opposite over hypotenuse, so that's going to be square root 1 minus x squared over 1. But I'm not, just rewrite those. Negative 1 over square root x squared. Now that's interesting. Isn't that what we just had?
No, it's negative.
It's negative, yeah. On your blue sheet, do I have inverse cosine at all?
Yes.
Oh, okay, great. So, summary statement here, d over dx, inverse cosine, we'll go ahead and jump straight to u, is negative 1 over square root 1 minus u squared times u prime. Wasn't that so much faster, too? Big lesson. Huge. What's next? Tangent. Let's do it. Y equals inverse tangent of x. And by x, I mean x over 1. So y is the angle. And then this is the weirdest thing. Look at this. So x over 1, that's the ratio. That's the ratio of the y value over the x value. So for the y, I'm going to put, for the y value, I'm going to put x, and for the x value, I'm going to put 1. Floyd, does that make sense? That's what I mean, because like, they say, what's the inverse tangent of
It's
x
opposite
over?
over adjacent, so it's opposite even.
Yeah, that's what it is. It's just those. I mean, I maybe I could have put like, I don't know, b or something. Y was inverse tangent of b, but we used to put inverse tangent of x, so. Alright, now we can figure out what the hypotenuse is. So, question mark squared equals x squared plus 1 squared. So, question mark equals the square root of x squared plus 1. We normally, though, just because on all these other ones we have the square root of 1 minus, on this one we tend to write it as the square root of 1 plus x squared. Rather than x squared plus 1. Just kind of helps us. Alright, let's get going here. We'll go ahead and take the tangent of both sides. Tangent of y equals the tangent of the inverse tangent of x. So tangent y, or tanny, equals x. Let's go and take the derivative of both sides. So we're, what's that? Secant squared y, or sec e? Sec-y? I don't know, I'm not sure. Anyway, times dy over dx equals derivative of x, 1. So dy over dx equals 1 over secant squared y. Now, if you remember your reciprocal identities, what is 1 over secant squared? Do you remember the reciprocal of reciprocals? No.
Oh, is it? No. I mean, it's.
Secant by definition is 1 over cosine. So 1 over cosine.
Would it just be cosine?
Yeah, just cosine. Well, or cosine squared here. It's because it's the numerator times the reciprocal of the denominator. So. Alright, so let's deal with that. So cosine squared. So I'm going to write cosine ratio. So the cosine is the adjacent over hypotenuse with the x value over the r value. So that's 1 over square root 1 plus x squared. And then all that is going to be squared because it's cosine squared. 1 squared is 1, and square root of 1 plus x squared is 1 plus x squared. By the way, that's all equal to dy over dx. So, add another one on the list. The derivative with respect to x of inverse tangent of u is 1 over 1 plus u squared times u prime. Now you might wonder, is the inverse cotangent, or the derivative of inverse cotangent, negative that? And the answer is yes. I'm not going to make you do that. Negative 1 over 1 plus u squared times u prime. Alright, we've got 5 minutes. Can we do one more? I feel like we're getting faster at this. Alright, 5 minutes. Here we go. Secant and cosecant. Y equals inverse cosecant of x. That is to say, inverse cosecant of x over 1. Now you might not remember what inverse secant is, but that is the r value over the y value. So the r value is x, and the y value, or no, hold on, secant. It's r over x. So the x value went from 1. Sorry about that. It's not r over y, it's r over x. So, question mark, we don't know. So it's 1 squared plus question mark squared equals x squared. So the question mark is going to be x squared minus 1. So the question mark is square root x squared minus 1. Here we go super fast. Secant of y equals x. Take the derivative of both sides. What's the derivative of secant?
Secant y, tangent y, dy over dx.
Yep, secant y tangent y, dy over dx equals 1. So dy over dx is 1 divided by secant y tangent y. So secant y is going to be, so that's the r value over the x value, so x over 1. Tangent y, tangent is the opposite over adjacent, or the y over the x, so that's going to be square root x squared minus 1 all over 1. So it's literally 1 over x times the square root squared minus 1. You were talking about ugly. Alright? And notice x in this case is that distance, that's that hypotenuse. It always has to be positive, so we forced it to be positive by putting absolute value symbols there. So our last option here, the derivative with respect to x of secant of u is 1 over absolute value of u times the square root u squared minus 1 times u prime. And the derivative of inverse, sorry, that's inverse secant. The derivative of inverse cosecant is just negative of that. And your blue sheet is almost filled up. Today we talked about the inverse trig function derivatives. I can't believe we got it done in like 25 minutes. That's awesome. I will have a homework assignment associated with this for you tomorrow. And we'll do some problems on it. Yes, come on up here.